Welcome to Data Center Dialogues, the podcast where we explore the trends shaping the future of digital infrastructure. I'm Alison Matte, and today we're diving into a topic that's transforming how data centers operate: AI-driven condition-based maintenance. Think about this. Downtime in a data center can cost thousands of dollars per minute. Yet, many facilities still rely on calendar-based maintenance, fixing things on a schedule, not based on actual need. And that's changing fast, thanks to AI. Before we jump in, a quick listener-friendly distinction. 2025 report, Transforming Data Center Services, AI-driven condition-based maintenance, draws a line between asset-level monitoring and systemic condition-based maintenance. Asset-level monitoring tells you how one UPS or one cooling unit is doing. Systemic condition-based maintenance, or CBM, looks across power, cooling, and IT load together, so you can detect risk earlier, prioritize the right intervention, and avoid fixing the symptom in the wrong place. The report also links this approach to measurable outcomes like reducing on-site maintenance, interventions, and lowering maintenance contract total cost of ownership, especially when CBM is embedded early from the design phase. And we'll reference EcoCare today, Schneider Electric's connected services model that brings remote monitoring, analytics, and expert support together so service is triggered by condition and risk and not by a calendar. Joining me today is Cristene Gonzalez Wertz, one of the authors on our 2025 report, Transforming Data Center Services, AI-driven condition-based maintenance.
Thanks, Alison. Excited to be here.
Let's start with the big picture. Why is the industry moving away from reactive or calendar-based maintenance towards AI-driven condition-based strategies?
Alison, there are a lot of reasons, but it comes down to two key drivers: complexity and talent. Data centers are doubling globally by 2030. The technology is moving fast, and facilities are coping with unprecedented levels of change. Equipment, sizing, functionality, and all of that comes with aging infrastructure, tighter commissioning timelines, and continuing workforce shortages. We just don't have a shortage of techs. We're asking techs to support more types of systems across broader areas. Traditional maintenance models where you service equipment every 6 months, whether it needs it or not, just don't hold up anymore. Service on a schedule can tie up OpEx, it can strain talent the industry needs to deploy mission critical tasks. AI-driven condition-based maintenance uses real-time telemetry and predictive analytics to determine when an asset actually needs attention. It's proactive, not reactive. And this is not a future capability. Schneider is doing it today in our collaboration with Compass Data Centers. Because we've designed censored specific equipment and connected systems, we've cut intrusive on-site maintenance by 40% and reduced operational expenses by 20%, all while maintaining reliability.
Wow, that's huge. This feels like a shift, right, from check-the-box maintenance to intelligent service. How do you frame that for executives?
Spot on, Allison. This transitions us from time-based to insight-based decisions using software to drive services. I often use this analogy. Imagine taking your car to the mechanic every month, even when nothing's wrong. It feels like a waste of time and money. Today, our vehicles are using algorithms and alerts. So you get messages akin to, based on how you drive and current wear, your brake pads will need attention in about 500 miles. As an example, it's simplified, yes. But what AI brings us and brings to data centers is this same ability of identifying the patterns, predicting the issues, and intervening before they become problems, in this case, outages. And even greater value shows up when you look across, as you were discussing earlier, these connected systems. Cooling, power, and IT load don't operate in silos. Understanding how they influence each other is where the complexity and the value really emerges.
It sounds like this approach is really a differentiator. It delivers technology leadership, deep benefits for customers, and cost efficiency. So let's kind of break that down, starting with the technical side. What makes this possible? What's under the hood of AI-driven condition-based maintenance?
Oh, we're keeping the car analogies going. Okay, it starts with IoT sensors embedded in critical assets, power systems, cooling units, UPS batteries. These sensors feed data into Schneider Electric's EcoCare services and IoT analytics platform, which uses machine learning to detect the anomalies and predict the failures. We're talking about continuous remote monitoring, real-time asset health scoring, and predictive models that learn from historical and live data. This isn't just about one piece of equipment, it's systemic, and each and every asset is part of an interconnected energy chain. The algorithms we're using are continuing to learn about each sensor, but also all of them as a whole, and that's the systemic view. No asset operates in isolation. So I'm going to go back to my utility background for a second, part of my past work. So let's say a transformer keeps throwing repeated alarms. So the load limits are adjusted and the transformer is flagged for replacement. Costly, but the alarms still persist. The sensor was working exactly as intended. It reported correctly. The challenge was in the unbalanced load and even uneven charging patterns. So the transformer was not failing. It was simply absorbing and reporting volatility created elsewhere. Sensors show you where the stress occurs. AI and broader inputs across interconnected systems help you determine the right places to intervene by examining a deeper and a wider set of inputs and interactions to make smarter decisions.
So, if I summarize, you can use all of those vital resources more effectively. That makes sense. Let's talk outcomes. We've mentioned Compass Data Centers, our key customer collaborator on this project. According to the Compass account leader within Schneider, John Muscatello, scheduling services based on what the data says is much more cost effective and accurate than time-based maintenance cycles. It reduces planned and unplanned downtime, since humans entering the data center raises the greatest risks. He also notes the additional benefit of cost optimization. Our work with Compass started with a service-ready solution, right? By that, I mean we had designed in the sensors an approach for servicing the hardware from the beginning.
Absolutely. By planning for IT instrumentation in the design phase and leveraging a modular build for consistency, it increased the understanding of performance so we can significantly reduce the frequency of preventive maintenance interventions for the systems and the equipment. Schneider's condition-based approach to servicing can deliver, and in fact has delivered, substantial cost savings benefits amounting to an estimated 20% reduction in services costs. According to our colleague Wendy Runyon, who worked heavily on this first of a kind data center, Compass was very direct in approaching us to innovate with them. Wendy noted that we had to go well beyond automating manual checks into digital dashboards, which is generally kind of the first line of defense. But Compass gave us the mission of re-engineering from the ground up, scale for AI demand while facing labor shortages and rising OpEx. So the solution we built and the one we manage today harnessed condition-based and predictive maintenance in that solution from day one.
And correct me if I'm wrong, but the results Compass is reporting are 40% fewer manual on-site interventions and 20% lower OpEx, all while increasing speed to market for hyperscale deployments.
Those outcomes aren't anecdotes. I came to Schneider having worked with manufacturers, electronics companies, and utilities who were early adopters in condition-based maintenance at scale. The Compass data center results mirror what we see across infrastructure sectors implementing predictive maintenance. This solution gets more powerful over time, not less. Independent studies show AI predictive maintenance can cut unplanned downtime by 35 to 45% and reduce maintenance costs by 25 to 30% by identifying the degradation patterns long before a human or schedule would. So they are right in line with what we're seeing from Compass.
In one of our discussions, you say that the value compounds fast in data centers because failures rarely happen in isolation. Can you build on that?
I can. Most equipment providers support their stuff. That's logical. If I sell you a cooling system, my company has the most knowledge to service it. But a cooling system interacts with multiple other systems in the data center. Cooling dynamics affect power usage. Power quality affects IT load behavior. Workload swings affect thermal stress. Understanding how one thing behaves may or may not explain how the whole system evolves. That's where AI becomes the connective tissue that links between these signals, revealing systemic interactions, not minimizing complexity, but understanding it and creating insight at the same time. Predictive maintenance, coupled with algorithmic depth, such as the multiple algorithms that are sitting behind our software in this system, upgrades that mechanics checklist to a systems intelligence layer that prevents outages by assessing how the whole system behaves under real load.
So Compass didn't just adopt a new maintenance model. They create a new way of seeing the data center as an interconnected system where insight, not time, sets the operational rhythm. We know that academically, but this is making it a practical reality. It's really impressive. Cristene, how do you see this resonating with CIOs and CTOs?
It's a resilient story, and we know that it's not just about reliability. It's got to be about resilience too. As a matter of fact, EPRI, the Electrical Power Research Institute, estimates outages cost businesses 45.7 billion annually, estimated, but seriously, 46 billion. Okay, even a brief downtime can be catastrophic for AI workloads or financial transactions. AI-driven CBM isn't just cost optimization, it's risk mitigation.
So looking ahead, right, when you're talking about risk mitigation, what's next for AI in the data center services?
Okay, we are embedding AI deeper into service workflows and digital twins. At Schneider's Innovation Summit, we unveiled EcoStruxure Foresight Operation, an AI-powered platform that unifies power, energy, and building systems. It boosts operational efficiency by up to 50% and resolves interrelated issues a whopping 90% faster. But I think you know more about that than I do. So I'm going to turn the tables for a minute. Alison, can you help me understand foresight a little better?
Sure. EcoStruxure Foresight Operations integrates three major system domains: energy, power, and building systems, bringing them together into one AI-powered operational platform. In short, this convergence provides full visibility, predictive insights, and centralized control across the entire built environment.
Wow. I can't wait to hear more about foresight over the coming weeks. But with condition-based maintenance, and this is the final word, and I know it's near and dear to your heart, we don't forget sustainability. AI-driven maintenance reduces unnecessary truck rolls and it optimizes energy usage, helping operators hit aggressive carbon targets and being more responsible with their resources.
This has been a fascinating conversation. We've gone from reactive maintenance to predictive intelligence, and it's really clear that AI is rewriting the playbook for data center services. Cristene, thank you for sharing your insights.
Always a pleasure.
And to our listeners, stay tuned for upcoming episodes in our inaugural season where we'll explore more around data centers. That's a wrap on this episode of Data Center Dialogues, powered by Schneider Electric. I'm Alison Matte. Thanks for tuning in. If this was valuable, subscribe, rate the show, and share it with someone on your team. See you next time as we dig further into the future of energy tech.
The content of this podcast is for informational purposes only, should not be undertaken as financial, economic, legal, business, tax, or investment advice. The information, statements, views, and opinions should not be construed as the provision of advice by Schneider Electric or as an offer to buy or sell any products or services or to make or consider any investment or course of action.